fiber. We will enjoy barbecue and beer and I guess other libations if you partake. And just enjoy networking and a little bit of a Texas experience. So hold on to your hats. We have a full day. We're starting out with a great topic. Yesterday, we heard a lot about ICANN. Today, we're going to start out with information sharing framework. Mr. Rob Dew is leading this presentation. He is the Senior Technology Advisor for Emergency Communications within Cybersecurity and Infrastructure Security Agency and has been in that role since 2018. In this capacity, Rob provides overall technical advisement on design, development, testing, and deployment of priority interoperability of next generation network priority services, wireless priority service, long-term evolution transition to 5G, secure data exchange, Internet of Things capabilities for emergency communication stakeholders, and more, I'm sure.
Anything else?
Someone was throwing every buzzword in.
Yeah, exactly. They're all there. They're all there. In short, Rob knows what he's talking about, so we should listen to him today. He is going to get us started with this presentation. We're going to see a demo of some of this technology, and then we're going to turn it over to Ms. Carla Jurens, who's going to lead a panel discussion. We're grateful for Carla and her willing to do that. Carla is from the Texas Department of Public Safety and has been since 2009, Texas Statewide Interoperability Coordinator. So who better to lead this discussion? Joining her panel is John Contestable, Director of Public Safety Technology Solutions at Skyline Technology, and of course, the illustrious Dr. Walt Magnuson. And finally, I'm going to just give a shout out to my colleague, Michael Fox, who's the man behind the curtain, who's making it all work. I think Walt did a great job of pointing out everything that Michael has done to make this week a success. I think most people don't realize that he's working on the entire week. He's not only working on the exercise, he and his team are making it work. So Michael, thank you for everything that you've done. Okay, so Rob, I'm turning it over to you.
Yeah, so we, one of the things when I took the job coming from industry at CISA was, we had a lot of things. We were looking at the security of data. We're looking at the priority of data across the wireless networks, but there was a problem of how do you share disparate data between public safety responders that may be on different wireless networks in different enterprises and different jurisdictions. And there's been a fair amount of work done and some building blocks put in place, but I hadn't seen anything that was holistically looking at this. And a lot of this was mentioned yesterday. So when Matt was talking about GTRI with the ICANN and trust marks, that trust marks framework, that's kind of a level down from the level we're talking about, where you're looking at the information exchange of a secure identity, identifying someone before you set up the data session with them. Who are they? Do they have the right to see the data? The drone presentation had another good example of where you want to have GIS, you want to have your LMR and your LTE, and then you want to bring drone footage, maybe from a real-time video, onto one screen. So the genesis of this project was really to try to, go and get public safety together, write a document that kind of put all the needs that public safety needs for information sharing into one document, then go out and start meeting with stakeholders to try to get a lot of operational requirements. And now we're at the stage, which we'll talk about, where we're looking at talking to industry and looking at doing technical POCs to see what's the art of the possible with this. Because a lot of this, when we started, it really is kind of like boiling the ocean. You're not specifying a specific application to share data, but you're kind of like sitting right above that level. And we'll get into some of the specifics of it. Oh, so yeah, Jonathan's got it up there. So yeah, so today we'll talk about real quick the project origins, the ISF background. I talked about this in January 2020 when I was here. Last time we had a face-to-face interop. And then, so the last time I was here in January 20, we were still working on the document. So the ISF document actually we finished it in December 2020, the government being the government, it took about November 2021 to get it approved and published on the SafeCom CISA website. We've done we actually did one focus group in Houston last July, which we'll talk about. We're engaged right now out in Iowa, looking at from a state level, how they've got about 113 PSAPs connected together on their own fiber ring, ESINet connected. how can you look at data interoperability of CAD to CAD within that environment, and as well as looking at NG 911 media that's coming, how that will be ingested into the system, and then potentially go back out across the SENet to first responders. So we'll talk a little bit about that. The operational POC is really what you're going to see today is to really give a functional view of what it could look like. And there's two phases to it. We'll go through that. But we wanted to do an operational POC and get feedback from stakeholders. So this right here is really the first phase of that. So as we go through this and we show the demo, we're really looking for feedback from the stakeholders to say, is this something that would really be useful before we start going in and spending a lot of money on a technical POC. And Michael Fox helped a lot with that, and John Contestable really made it happen with the video sharing demo that we're going to show. And then we'll move to the technical POC and talk about some of the stuff with industry. So I work in the emergency communications division at CISA, that would be the cybersecurity and infrastructure security agency. And kind of our North Star is the National Emergency Communications Plan. And if you want to map kind of what we're doing with information sharing to that kind of overall North Star for emergency communications, here are the three objectives, 5.1, 5.2, and 5.3 that have to do a lot with interoperable communications and securely sharing data. So this is kind of where it sits in the grand scheme of things in emergency communications. Next slide. Okay, so John has been working for a long time on this three-layer concept that he'll get into, but we were meeting at SafeCom and NICSWIC meetings, and we were doing a lot of presentations on, we felt we really need to start addressing this, and we wanted to do it through SafeCom and NICSWIC because those are the public safety stakeholders, those are the users. We wanted to get what they're really looking for first before we started approaching industry. So John and I have been doing multiple presentations. Finally, in April 2019, we got the okay to set up a SafeCom NICSWIC task force to actually look at this. And then we actually met face to face in August 2019. I think that was APCO in Baltimore. Like I said, we finally finished the document in December 2020. What we wanted to do, the goals with the document was really to have one document of kind of like a Venn diagram of all the data sharing that public safety has been doing, a lot of the standards. We wanted to have one document that anyone from a technical person to emergency communications management could go to and look at. So it deals with technology, people, processes. It's not just a technical document. It's not just a governance document. It's trying to hit everything at a very high level. And when we built the task force, and Walt, by the way, is on the task force, Sheriff Fitzgerald out of Story County, Iowa, was our co-chair, and then Chief Lewin, who was with Chicago PD, I think he's now with FirstNet, was our other co-chair. But we wanted to build the task force with technical people, policy people, and operators. We wanted representation from dense urban areas, suburban areas, and rural areas. And we wanted to make sure that it was really developed by the stakeholders. And we really, ultimately, the goal of the framework, what we wanted to do was put a document together that gave a mechanism for public safety agencies to share data during a big event from different jurisdictions on different wireless networks. How do they go about doing that? And the ISF can really be customized from, trying to come up with an information sharing scheme to respond to a massive earthquake, all the way down to if you just want to look at tying some CAD systems together, what should you look at? And we also wanted the document to be an acquisition document that if you're going to go purchase a network service or product, it would give you kind of a checklist to go through, like what are the regulatory issues, how are you going to manage the data, how are you going to handle security at a high level. And then we wanted to also look at some of the data standards that were out there, and then what were the technologies. A lot of companies out there that can kind of contextualize data, so you don't necessarily have to put everything through data standards. There's a lot of technology we can decorate or contextualize the data, and that will usually be good enough. So those are kind of the goals of the document, and then some of the groups that we had as part of that. So this is a graphic of the former Delaware SWIC, Mark Grubb, and he's working at EDCD now. He came up with a couple other people, and this is really, all of you know this here. So you know the complexity of emergency communications. They got everything coming together under IP. You've got LMR, you've got LTE, 5G, you've got alerts and warnings, you've got NG 911, you've got CAD systems. We talk about in areas where you might have network damage, you're going to have drones deployables, you can have satellite communications. These diagrams are really for SWICs and emergency responders to let their management know at the state level, this is how complex this is. And this is why, like at the state level, you really need to have something like an interoperability board where you're bringing together the NG911, the LMR, the wireless broadband, the alerts and warnings, a lot of different things that are different technologies, different networks that are all coming together kind of under one umbrella that all have to interoperate. And you don't know, depending on the type of emergency you're having, you know, what's the medium that you're going to be needing priority, security, and interoperability across. So obviously in dense urban areas, you have a big problem with a lot of people. You get a lot of congestion and you get a lot of interference at frequency bands below 6 gigahertz, which causes a lot of issues. But then you go to rural areas and you might not have anywhere near the bandwidth. You might be well outside the LTE or 5G coverage. You may not even have LMR coverage, and you may be doing satellite. And so we wanted to show the complexity of the two kind of opposite ends of the spectrum. Next slide. Okay, I'm going to hand this off to John because I'm more on the technical side. John has been working with public safety for decades, and so he makes a really good team. So.
Thank you. Good to be with you this morning. What is it? We go howdy?
Howdy.
Howdy. That was a little weak. Let's do it again. Howdy?
Howdy.
There we go. I almost bought a t-shirt that said that, but my East Coast friends wouldn't understand, so I didn't do that. Thank you, Rob. Yes, we've been talking about this method of approaching interoperability for some time. When I was a SWIC in Maryland back in the day, there was no guidebook, there was no rule book, there was no how do you do this. And I was the SWIC under Governor O'Malley. Some of you might recognize that name. And you know, I said, man, what have I gotten myself into? And we've tried to put together in this document, as Rob said, kind of a comprehensive approach to how you look at the interoperability challenge. And as Rob said, it's not just a technology challenge. We like to use the term people, process, and technology. In fact, you can steal that and use it because I've learned in my many years at this that it's never the technology. The technology can be made to do almost anything you want it to do. It's almost always the people and the process sides of the equation that are difficult. So what do we mean? People. Do you have the right people at the table? In your state or your organization, do you have the NG911 people there? Do you have the land mobile radio people there? Do you have the IT CIO types there? And so do you have the right people around the table? And is there a level of trust between them? Because, you know, we've all heard the stories, you know, that fire chief doesn't like that police chief, and I'll be damned if I'm going to share any information with him or her, right? So, you know, you have to have trust amongst the parties in order to break down the barriers to share information. So it all starts with the people. And then even if the people agree that they want to tackle this interoperability challenge, you have to have some sort of process that they can work through that yields a product. And that product might be a concept of operations, some action steps, some sort of governance structure, but you got to have a product that those people can come to an agreement about, which actually says, this is what we want to do, and this is how we want to do it, okay? So you start with the people, work through a process, you achieve some sort of consensus, and then you apply the technology. Now, how often do we get it asked backwards, right? We go buy a black box, we roll it out, and then nobody uses it, and everybody goes, my gosh, nobody used it. And it's, well, we had grant money, we had to spend it by August, so let's buy the box, right? And so we get it backwards all the time. So really, we have to pay attention to this. Next slide. So here we go. Another concept that we wanted to run over here with you folks is that in the old days, we used to build what we would call separate systems, okay? You had your system, I had my system. The good news about that is if my system broke, it didn't affect you, right? So everybody was fat and happy and did their own thing, right? Now, at the other end of the spectrum, you see what we might call fuse systems today, right? Well, fuse systems are, let's use land mobile radio. When you're sharing tower space, you're sharing backhaul, you're sharing same handsets, it might be a dual band system, 700-800 system, okay? So that's where you have a really tightly integrated system. And there's ways with IP today to parse out these channels are for you and these channels are for you. So even though you're on the same system, you still kind of have your own little. The problem is when you move out to a fuse system, you know, I can't do what I want to do on the system without thinking about you because we're both on the system. There's certain protocols we might have to agree to, we might have to share. So the reality is Even though in the name of interoperability, we had no functionality here. We would swap files by actually running a thumb drive across the room, okay? And over here, we've got great interoperability. And we actually might save some money because we're sharing hardware and backhaul and other features, okay? The reality is, nobody does this much anymore. Why? Because nobody has enough money to do their own thing anymore. So you see regional CAD systems, you see regional land mobile radio systems and the like. But this is also really hard from a governance standpoint, okay? So the reality is we should be looking to be somewhere on this continuum in here. How interoperable do we want to be? How much information sharing do we need to have? And how does that be reflected in the technology in terms of what we share? So this is a good graphic where we say, you know, I want to be more interoperable. Well, that's like motherhood and apple pie. Question is, how do you need to be interoperable? What do you need to share? With whom do you need to share? Where do you fall on this continuum of sharing technology? So that's the conversation you need to refine if you're in this business. Next slide. The next two slides are really the heart of the matter. Imagine, if you will, a three-layer architecture. And we call this the three-layer cake. The bottom layer is the data layer. This is basically where the data lives. And if you think of your agencies, this is typically a system that was purchased oftentimes many years ago, and oftentimes not designed to share information outside of that system. So it sits in a server in the basement of the building, and it sometimes is kind of fragile. You go talk to the IT person and you say, so-and-so wants to see some of my data, and they grab their heart and they start claiming cybersecurity. We can't do that. And so this is where the data lives. And it doesn't matter what data it is. It could be video, it could be audio, database, sensors, it doesn't matter. Maps could be a GIS system, but this is where the data lives. This is the legacy system that was usually purchased without data sharing in mind. If you will, look at the top layer. The top layer is the presentation layer. That's where the data needs to go. That is you in the field, the end user who needs the information. And where does everybody want the information today? On one of these, right? So the challenge is for interoperability. How do you get the data from where it lives in some sort of clunky system behind a firewall with a CIO who doesn't want to allow access to anybody outside the agency, to the presentation layer, to a first responder in the field, or a utility worker in the field, the transportation worker in the field, who needs that information? Well, what we've learned is you can't achieve interoperability at the data layer. It doesn't scale. If you can build onesie-twosies connections between data sets, that's fine, but it doesn't scale when you want to do it more broadly. So what we've concluded is you need to build an integration layer. It's not realistic to ask or expect that the data layer of system owner is going to make changes in this system in order to share information more broadly. So next slide. This is kind of the integration layer blown up or expanded. So we say, okay, if you need to build an integration layer in order to share information across systems and users, what does the integration layer need to do? Well, basically, it needs to do 5 things. It needs to do discovery. How do you find the information that you need? Okay. I'll use an example, might help here. Let's imagine, if you will, you're a police officer, you're at an intersection, and there's been a pedestrian struck. And the officer responds to the scene, looks up, and he sees a camera on the light pole. He says, okay, well, we just had an accident, pedestrian struck. Eyewitnesses said a blue car struck this pedestrian. Sees a camera. Question, discovery, who owns that camera? So you got to be able to find the data source, first of all, right? So what data do you need? Can you find it? The second is identity management. Do I have rights in that system? Let's say it's a Texas DOT camera. Can I get into that system and see what happened a half hour ago when the pedestrian was struck? So you have to have identity management. Can I authenticate into that system? We saw a lovely presentation yesterday. Matt's still here. I can, thank you. But it fits into this framework, okay? So can I get into the system? Do I have rights? Okay, I found who owns the data. I can get into the system. The next is, can I actually do the data exchange? So if you've done any work in the video world, video systems are just as non-interoperable as land mobile radio systems. And so, is it a Genetech system? Is it a Vidsys system? Can I get into it? So you have to actually do the data exchange. What's the format of the data? Is it JSON? How are we going to do the exchange of data between systems, okay? And then lastly, you got to do some, second to last, you got to do some analytics. Because I don't want the video now, I want the video from a half hour ago when the accident occurred. And on top of that, I'd love to be able to search for the blue car. So I don't have to look hours of footage, right? So you have to do some analytics to get what you need. And then lastly, as Rob is eloquent about, you need transport. So if we're going to send it over FirstNet, wake up the people in the back. If you're going to send it over FirstNet, what's the protocol for me sending video to the FirstNet network to carry it across the wireless network to the smartphone? Okay. So the 5 functions of the the integration layer is discovery, identity management, data exchange, analytics, and transport. So when you say, how do you become more interoperable? You have to pay attention to those 5 things. Okay, so when I was a SWIC, there was no rule book, there was no direction. This is what we've learned. Those are the things you have to worry about if you want to make your data sets more accessible or interactive. So that leads to some questions. If you want to discover the data and you're the mission owner, if you're the officer in the field, what data do I want? Does it exist? Where is it? Who owns it? Can I get access to it? As far as identity management, how do I persuade the owner to provide the data? How do I prove that I am me? Those are the questions that you should be asking as a SWIC, or anyone that just wants to share data, for example. So these are the real life questions that this model tries to drive you towards. So instead of just saying, yeah, we want to be more interoperable, this is like how to do it, the component pieces and parts you need to pay attention to, and some of the questions you need to ask.
Let's say one thing real quick, but, on the previous slide, so we just wanted to make it clear that the discovery, identity management, data exchange, those are things we really want to see common among vendors and service providers. But the analytics, you see that's custom in the integration layer. So there's a lot of room for the vendor community in the analytics part being interoperable with the other integration layer functions to really still keep a lot of that secret sauce. And then obviously the transport is kind of common and custom, and then there's going to be 3GPP standards for priority, preemption. There's going to be access class barring and all that kind of stuff. There's certain standards for security, but you can still do some things in the transport. A carrier can have more capacity or more redundancy or a slightly more optimized topology than maybe their competitor. So even though a lot of vendors are used to maybe owning all 3 of those slices end to end, like John always uses the example of Apple, which is a good example. There's still a lot of room to play, even though you're making things very interoperable.
Yeah, thank you for doing that. I always seem to miss that point, but we like to call it a slice of the 3-layer cake, where the agency wants their system to be the data input system, the data manipulation system, and the data presentation system. What we're suggesting is that slice, while it's tightly integrated and gives a nice experience, user experience, thank Apple, it doesn't play well with other information sources. It doesn't merge well with other data sets. So that's important. Rob, I think you have the next slide, and then I'm going to jump back in.
Yeah,
Michael, you'll be up in a minute.
Yeah, so we're going to go to the demo here in a minute, but we wanted to talk about, so we were talking, we had the task force, we wrote the document. Now we're gathering a lot of operational requirements. So part of that's like focus groups. So last July, we were in Houston with SWAT, fire, police department. And if you remember Walt yesterday, when he did his introductory presentation, he was showing the 8 NIPSTIC IoT use cases and how you need, information sharing becomes ever more critical as the scale gets bigger. And the use case we used was the active shooter. So we had an active shooter in a school, and we stepped through and we said, what data do you need before the event, during the event, and after the event. And we knew this was going to be much more GIS focused and video focused. And, a lot of the data that was required for this that everyone kept saying was, we want eyes, particularly if we could get it inside the school, if we've got access to the security cameras, we need attendance lists of the students. We need floor plans and a lot of GIS because, if it has to be like a SWAT team has to go in eventually, they want to know exactly where the active shooter is, exactly where the children are in relation to one another. So, the goal of these focus groups is to take this ISF framework that we did build with public safety stakeholders, but start customizing it for different use cases and see how valuable it is. I mean, is it valuable? Is it really drawing out the kind of gaps that you might have in networks, operational procedures, technologies? The other one that we started, and Chris Mayers is a SWIC for Iowa. He's actually also on our ISF task force. I should also say Carl is also on our task force as well as for Texas. So, and getting very valuable information from them. And Chris came and he said, look, we've got 113 PSAPs. They're on the Iowa Communications Network fiber ring. They're all SENet connected. We're doing voice and we're doing text to 911, which is kind of over the top right now with texting. But we're really in a good position to start looking at NG911 and cat-to-cat interoperability. And, within counties in Iowa, the CAD systems are tied very tightly together. But when you start going into cross counties, that's where, they don't have the ability to completely share all the data that they want, whether it's XML or JSON, and they're always having to write all these conversion tables. So what we're doing is we sent out a survey. We talked to a lot of the representatives of the counties around Des Moines, including Des Moines Police Department, Des Moines Department of Public Safety. And what we're doing is we're building a customization of the ISF to say, okay, what do you really want to do? How do we go from that data layer where you have that CAD data on one system, let's say Spillman, and then take it to an integration layer, share it and present it onto another CAD screen where the icons might be different, that may be another system. And so the hope in that, and I'll get to it after the demo, is how we start tying all this stuff end to end across the emergency communications ecosystem. But the Iowa project is very much focused on NG911 data. How do you bring that in? How do you ingest it into a CAD system? How do you then turn around and send it back out, which it may be EIDO or something, or EIDD, the data format out to a first responder. And I know later in the day, we've got a lot of other panels that are very much tied to this. We've got NG911 PSBN interconnection, which is a lot of things that we haven't really looked at that. How do you scale that? How do you deal with that for congestion? But anyways, these two are two different customizations of the ISF and kind of different use cases, but they're all kind of driving towards the same goal of being able to provide a document. So if you do want to go procure something like, say, the CAD vendors, you say, okay, we know NG911 is coming. We want to share data with our fellow counties. We have this vision of an ecosystem that we want to see. How are you fitting into this ecosystem? And so having the vision, but then also going down to the technical and operational requirements. So I think the next slide is, yeah. So just to reiterate, John, you want to go into this? This is an exemplar of video sharing in the ISF for the demo that we're going to show.
Yeah. This is just kind of a refresh to say, okay, you've got the three layers, the integration layer and the presentation layer. Next slide. Michael, you can come up in just a minute, but this is basically Texas A&M's version of the three-layer cake and what we built for this exercise. And functionally, we're going to have fixed cameras that are part of the data layer. They're also bringing in drone cameras to be part of that ecosystem. And we're going to publish that information to the presentation layer. And we're using two solutions in the integration layer, the Skyline distribution box, as well as an API from the Skyline solution, which then publishes into a web portal as the presentation layer, which is a tool called Claris, and that's what Michael's going to show off in just a minute. And then also we're going to publish into Bluetooth, Blue Force Tactical and Blue Force Command, which are smartphone end users, if you will. So this is an example. So in other words, the three-layer cake is not just, it's a framework to discuss the problem and to break it into its component parts, but it's actually a practical methodology to then start to chunk your different systems into the layer and look how you need to build those systems to do the information sharing you want to do. So the next slide shows basically the actual architecture. And if you're an IT person, this is the kind of graphic you want to get to. This is ultimately where you want to go, which shows the actual URLs and shows the actual paths and so forth. But the reality is we don't pay enough attention to people, process, and technology. We don't build that interim step of the previous graphic that kind of shows how to take the operational view and move it into this type of diagram. And so functionally and specifically, Skyline has a transcoding appliance that actually ingests, and by the way, this is flipped. So the data layer is at the top, if you didn't pick up on that. And the presentation layer is at the bottom, but I think you can make that leap, right?
But at least the colors match.
But the colors match, so. But these are the different source systems. The fixed systems is a Genetec system. And you can see the various drone systems on the top right. And they're publishing to a Skyline transcoding appliance. So that'll take whatever proprietary format video in and transcode it into H.264 format. And H.264 is basically what Netflix and YouTube uses. So you can open it with a browser. So you don't need to have a proprietary application on your phone or your desktop in order to see the video, okay? And then it pulls the image once into this transcoding appliance. And then what it does is through the API, it multiplies that image. So if you've got multiple recipients here, you can push it out of the Skyline API to those different sources, okay? And so this is what's happening in the integration layer with the data path and the video paths, as you can see. And then it's publishing into the Claris web portal and into Blueforce. And in the future, we're hoping to publish into text maps because this API, I know the text maps people were here the other day or yesterday, but the API can push it into ArcGIS in the format that can be consumed into ArcGIS. And so you could have other sources in the presentation layer. So fundamentally, what we're doing is we're consuming proprietary video information, standardizing it, normalizing it, and serving it up in a consumable way to the presentation layer. And that's what Michael's going to come up and just show us real quick. This is not intended to be a exhaustive presentation on the tools here, but just to show you that this isn't just Rob and I talking about something that would be nice, but rather it's something that's actually built and able to share information. So, and Michael's been great through this whole thing. Joan sung his praises earlier. I will second that motion because he's been working real hard to make sure that all the different URLs, work. And in fact, how we had to do this, we had to build some URLs and some hooks so that when someone walks up with a drone, you can say publish to this URL and it's RTMP or RTSP format, and it will be able to consume it and move it like we're showing in the graphics. So, Mike.
So we don't have time for the 30-minute lecture on protocols?
No.
No? Okay. Can everybody hear me okay? All right. So what we're going to show real quick is a couple of fixed cameras, and we're going to simulate drones. We don't have any drones flying right now. So what we did was took a couple of recordings that Dr. Murphy provided, and we're streaming them out via just a application on Windows called OBS. It just lets you play a stream. And it's streaming into the Skyline system using the same protocol that a drone would do. Okay, so the Skyline doesn't know the difference. It's just a video stream. And then on the output at the user level, we're going to look at the Skyline web portal. So that's one type of user. And then Blueforce provides web clients, but we're already seeing one of those. So we're going to look at a Windows application and a phone application. All right. So I wonder how to make this screen.
A little small.
Yeah, the resolutions aren't matching, so. Well, okay, that's good enough.
Where we are. We're here.
Right, so this is the map page for the Claris web portal. So cameras that have lat lawn associated with them will appear on the map in their locations. And of course, we can click on them and view the video. We can also look at a video wall. And what we've got. Okay, why aren't my videos there anymore? Well, that's easy enough to fix. Somehow they went away. Now they're back.
There we go.
Okay, so these are just a couple of fixed cameras. They're actually pan tilt zoom cameras here in the disaster city. And here we're seeing a couple of streams coming in from our server. So these are fake drone streams that we're sending into the portal.
Well, we gotta send someone out there to walk around.
Yeah, I don't know why that one's,
We'll realize it's actual live footage.
yeah. Well, actually, if you look at it long enough, you can see sometimes the wind will shake the camera a little bit. Oh, okay, there you go.
See, there you go. Thank you.
Well, I don't know why this one's not. So we used to say, when anybody here do demos for customers, how many people? Right, so we always say there's one of 1,000, any of 1,000 things can happen. One of them is everything works. So, yeah, so that one's not coming up for some reason. So that's taking these various streams into Skyline and then sending it out to a web portal. Now, another application would be a situational awareness tool, and Blue Force is one of those. And so Blue Force can do video, it does location. So as your team is walking around, you can see where they are. It does sensors and stuff like that. So, boy, this is just not behaving.
If you double click the top bar, it should size itself to the screen.
Yeah, it's just, I think the Teams thing has screwed up my screens.
Yeah, we're broadcasting this in Teams to some folks from GDIT.
Crap.
Yeah, one of our integration contracts.
So that's not helping with the presentation, as you can imagine.
Yeah, my screen is now frozen.
So while Michael's working on that, tying this into the exercise, so what'll happen in starting on Wednesday, Thursday, Friday, is we have scenarios that are going on during those 3 days, and there's a measle written against each scenario. So a measle is a master event scenario list. It, in essence, if this were a movie, that would be the script. So these tools are written into the measle. And what will happen then is incident command will have first responders go out and utilize these tools to accomplish certain tasks. So we need this building searched. We want you to use this tool. And so these systems will be in play then for the next 3 days. These aren't set up strictly for this part of the workshop.
Yeah, just give me a second. I'm relaunching this.
And a lot of the times we look at video because, as Rob can tell you, video can be the long pole in the tent for transport. If you don't size it right, depending upon the amount of bandwidth you have, it can be real problematic in the transport function of the integration layer. I will say that the Skyline integration boxes that we're using are tunable so that you can actually scale up or scale down the frame rate and the bandwidth out of those boxes. So if you know what the endpoint recipient, like this port is going to go to a phone, therefore we will dial it back to 15 frames a second and 192 kilobits, because that is wireless friendly.
It's this.
Whereas if this port is pushing to a video wall in an EOC, you'll dial it up to 60 frames and the full 2-3 meg stream.
Because it's like
Ethernet or
double
over
the screens and everything.
Right.
So the integration layer is helpful if it's tunable depending upon.
How do I
the
get
medium
out
that
of
you're
frickin'
pushing.
presentation?
So we look at video a lot because, one, it tends to be very proprietary. Most of the video formats the manufacturers put something in the encoding that will make it just a little off the standard, if you will. And so video tends to be very non-interoperable. And secondly, from a transport and the ability to move it around, it can be difficult. And so we use video in a lot of our examples to do that. So.
You want to go to the next slide?
Yeah, if we can move along.
Yeah, yeah, it's I don't know. Let's try this other one.
Well, Teams adds a whole new wrinkle to trying to make a demo work, as you well know.
Yeah, I shouldn't be running the meeting and doing this, I think is the problem.
But it works.
Let me,
Let's move on if we can to the next slide.
well, I'm kind of messed up right now.
And we're more than halfway done with the presentation, so.
be able to advance.
Can show you this real quick. So this is actually a Android phone. And so this is running the Blue Force application. And I can go in, for example, and let's say I want to view this drone. You can see the drone stream. So just an example of different clients accessing the same information.
And the importance of doing it in this methodology, again, the ISF is really a tool for you to use. If you build the integration layer right, then you can consume, standardize, and normalize, and publish the multiple application layer end user tools. So as an example, if you construct an environment like this and someone comes in with a drone, you just say, here, publish to this URL. And you're brought into the environment and served up. You only have to build the integration layer once, and it supports multiple presentation layer tools. So it's an efficient way to go about building your integration layer. Otherwise, you're going to be building individual customized interfaces between systems. And that's what doesn't scale, not to mention it can be costly, so.
Yeah, I think, well, so we can show a screen capture of the Blue Force. I mean, it was working. I think the fact we just loaded Teams on there. So what I wanted to point out was this previous slide is that most of what we're doing here for phase one of the operational POC is video sharing, a little bit of situational awareness, but you see all these boxes on the right. That's the stuff that we're going to be looking at integrating into the next phase. And so we're hoping to do an event or something in the August or September timeframe. It'll be the full operational POC. And so here is, I don't know, Mike, if you want to say a couple of words about this, but here's a screen capture of bringing it into Blue Force and publishing it into there. So, so as I said earlier, so phase one was really installing the Skyline video gateway, bringing in fixed cameras and drones from the data layer, putting them through the integration layer, where Skyline's kind of sitting in the integration layer as well as the presentation layer, then bringing them into Claris, which is like their GIS platform to bring video into, and then also bringing it into Blue Force. So for phase two, what we're looking at doing is to build and operate an API gateway that we used as the data integration layer function and to tie some common applications that public safety tends to use. We're looking at like WebEOC, Intrepid, and then GIS for use with CAD, and then ATAC. And there's a couple others that we're looking for as well. So one thing I wanted to make clear here, though, in the operational POC is the user experience is going to be the same as to what we're looking to move into the technical POC, but a lot of the stuff we're kind of, I'll say, kind of hardwiring in the background. There is some virtualization in cloud, but the goal would be over the next 3 to 5 years is to take this capability, put it in a cloud environment where it's like virtualized and there's software gateways. So the methodology with which we're doing this will be different, but the ISF principles still remain the same. So this has a, so I think we already talked about this. We went through we published the ISF document. We've done the focus groups. We're doing the Iowa pilot, and we're doing the data collection and analysis phase. Now we're coming out with all the requirements. Same thing happened in Houston. We're feeding those operational requirements into the technical proof of concept for a strategy to go to industry. That'll include technical, performance, functional, and the operational requirements. Go through the technical POC. Let's determine what we can actually feasibly do right now, and then talking to industry about how we would look at deploying this capability. So the one thing I wanted to tie this back to is where we're kind of going with emergency communications and 5G. So from the White House, our marching orders for wireless priority service, and wireless priority service right now is basically voice interoperability on 4G VoLTE. So if you want to make a priority call from one network to another, let's say you're a WPS user in Verizon, you want to make a priority call to T-Mobile, that's where WPS kicks in and has that interoperability between SIP, a priority on SIP messaging between the carrier networks. And there's over 20 wireless and wireline networks around the US and some allied countries where we have wireless and wireline priority for voice. But the next phase is moving into data, video, and information services. So now doing priority data, priority video, and the key here related to the ISF is really the information services. So we really haven't had the technology yet, but with 5G coming in virtualization and mobile edge computing and zero touch service automation, we feel that the technology's there now And a lot of the security, like the stir, shaken and other things between network interfaces are there, where we can look at tying different public safety users on different wireless networks and different organizations, allowing them to securely and share data with priority, even when sometimes that data is in disparate formats. Like, for example, video, like John talked about, maybe you're bringing in a 1080p camera at like 60 frames per second, but you need to publish it to a smartphone and you want to dial it down to 72p and maybe 15 frames per second because you might only have 5 megabits per second of capacity on that terminating link. All those kind of negotiations, or if you've got PDF files or Visio drawings or some kind of data that you want to publish into a cloud and make it available to another user, potentially on another network. So where we're going with 5G really ties into what we want to do with the ISF. And more specifically, just going back to the 5 integration layer functions, a lot of the goals that we want to do in priority communications, I mean, one is obviously availability on 4G, 5G. We're looking at doing that on Wi-Fi and satellite as well. But as we're doing data and video, now there's a lot of cybersecurity issues that come into play. So, usually you know who you're talking to, there are deep fakes on voice, but when you start sending data, there's a possibility for malware, there's DDoS attacks, there's, swatting where you may be sending false videos to try to get, public safety to go to some area where there's not really an incident. So there's a lot of security controls that we're going to have to put into the networks, and a lot of the issues with 5G being virtualized and APIs and mobile edge computing that it could be a whole topic on that on its own. But then also the priority interoperability and cybersecurity interoperability, like how can you make sure that you know who you're talking to, and if an agency comes into this environment, like trust marks would be a great example of those are the rules of the road for them to come into this environment. And then you can look at PIV and PKI and other things to actually authenticate and secure the two users in those different organizations. And then the performance and security testing requirements are going to be very complicated here because you're going to have multiple carriers, multiple technologies. You've got their cloud providers, you've got platform providers, you've got the orchestration going on within networks, and you have to have orchestration between networks if you're going to have something like a federated net network slice. So let me move along. So anyways, I just wanted to show that the integration layer functions are tied to where we're going with emergency comms and 5G. And then really quick, I think how are we doing on time? Are we almost out or a little?
5 minutes left, but that includes.
Right, okay. So this is kind of trying to show the 5G emergency communications priority service, like the architectural conceptual view. So I don't, do you have a pointer over there? I'm not sure if this is a laser pointer. It is, okay. Yeah, I just didn't want to like turn, I just figured I'd do it and would turn it off. Okay, great. So like, if you have an incident here, and let's say this is FirstNet and this is like Verizon and you want to communicate, you have to go through the wireless networks, and then you want to be able to have, and the way we see this going, it's not totally figured out, but it's probably going to be some kind of federated network slice as a service, which is basically, the advantage of 5G networks is you build one network, and then it's all virtualized. You've got third-party servers sitting in 19-inch racks, and then you've got remote radio units, and everything else is software, so that you can kind of dynamically build signaling and traffic in a network slice for a specific user with a specific priority, with specific security demands. But you want to be able to build that, not only here within the network, and in this case, we're going to IMS to do something like voice, but also have that honored end to end. You want to be able to look at the security, you want to be able to monitor KPPs, you want to be able to do a lot of things. And so what we're looking at is like a trusted interconnection here, where it might be like an SD-WAN, where you've got a third party that's a trusted party that is enforcing a zero trust architecture, but knows enough about what's going on here and here as well, so that when it does the transport integration layer function, like John was saying, if you're really constrained, for video here, then it wants to be able to tell the network, look, this person is going to be getting video, what are the congestion, what are the resource blocks in that PCI, that sector that they're in off that site. What's the best you can do with the resources you have? It needs to have some of that information so that it can force that, if it's mission critical data or it's some kind of multimedia priority service data, it can force that QoS between networks, and they can do handshakes, so that if you're under a service like, let's say, wireless priority service, or even if you're like Verizon Frontline and you're at AT&T FirstNet, there's some intermediary there that can negotiate that and understands the priority of both users, and understands the security they need, the type of network slice they're doing. The other issue is, let's say like the public wants to send a video once, I know NG911 video is a bit of ways off, Nina has the I3 MMS specification, but there's not really any networks or devices ready for it now, but assuming it comes at some point, a public user may send a video, let's say through Verizon here, it goes through Verizon, and eventually gets over here to the emergency communications ecosystem, so it's crossing the EZNet. Now that NG911 media has to go into a CAD system, well, first of all, probably before it hits the PSAP, there's going to have to be some kind of artificial intelligence or machine learning that's going to do data triage on that data to say, is this the 20th video about the same thing? I need to look for malwares or DDoS attacks in here, so a lot of security and data triage needs to be done. But then it goes into the PSAP, it goes into the CAD system, that now that video, an officer who's responding to the incident needs that video. So then that data has to be put in, maybe it's EIDO data format, some video format, that once it crosses back over to the wireless carrier, they know what to do with it. Like, let's take an example. Let's say this is a wireless priority service user and they've got like priority level 2 or 3. How is that information going to be known here so they know what priority to tag that with? And then once it hits the wireless carrier, they know how to build that network slice with the right priority and security. So we see the information services, a lot of the data that's going to have to be throttled or coded in a different way or decorated before it can be sent between users. There's probably going to have to be some kind of trusted interconnection here. So just to back up 1 minute. So the ISF process we put in the document, as we've shown here in the demo, and we had the CAD to CAD example, you can use that document to customize however you want to share data with other agencies. What we're looking at is it possible for us, without boiling the ocean and not being too complicated, it'll be complicated, to try to provide a service to users that they could use with those tools. And you need to service something that overarches between the carriers and can actually tie different public safety users on networks together. So I think I've got, one more. So we're still in the early stages of this. So there's a lot of issues we have to look at about how would we go about deploying this. So, what would be the roles and the responsibilities of all these different 5G ecosystem players? We've got the wireless broadband providers, we've got their cloud partners like AWS, Azure, we've got platform providers like VMware, Cisco, Dell Networks. What are going to be the role of those different 5G ecosystem players to be able to look at implementing an end-to-end emergency communications architecture like this, not only between the wireless providers, but also in and out of the ECC PSAP ecosystem. Transport, we kind of know how that's going to work. We've got QoS, we know we've got guaranteed bit rate pairs, non-guaranteed bit rate pairs. We've got quality of service class indicators for those to say, what should the latency be, what should the priority be, what should the throughput be. But some of the other integration layer functions, like the identity management, that's probably going to have to sit in some kind of trusted interconnect, because it's going to have to know something about the user originating the data and also the user that data is going to be terminated to. And so it's not crystal clear exactly where some of these integration layer functions are going to fit. They could be part in the cloud environment as well as the wireless service provider part, and also sit at the mobile edge computing at the, sit closer to here, especially for low latency applications like the XNet, that sort of thing. And also the ability to determine and track, KPPs end to end, like, a SIP interconnection agreement between carriers for voice is fairly easy to prove. You send the SIP invite with priority, you get the acknowledgement back with priority, you say, okay, it looks like we've got priority going across. But when you start doing data, a lot of that end-to-end view and KPPs associated that still have to be figured out. Like, and even cybersecurity KPPs. Like, for example, if you've got a network slice that's a high priority slice for public safety or an INSEP user, and the physical node that's going through, it has another network slice going through that's being attacked. What's the bits per second leakage? What's the degradation in those virtual functions that are making up that network slice? We have to understand what those KPPs are and how we secure them and view them. The other issue is the data formats. So there's no real global emergency communications data format that's widely accepted that's deployed out there in industry. So, CAD to CAD, EIDO, is that going to be it? So some of the data standards are still being kind of, have to go through conformance testing and that sort of thing. And then the key thing, which we're looking at right now, is that how do these integration layer functions get deployed? Can you deploy them as a holistic service? Probably not, because that's like boiling the ocean. Agencies have different use cases, different ways they want to customize it. So what we're thinking right now is, if we can make this deployed as a service, we're probably going to have some customized tools that go with it. So if you sign up for the service and you want to share data with another party user during a major incident, you're still going to have those rules and the framework, the peoples, the processes of what type of data you want to share, who you want to share it with. But we're thinking it's going to be probably a service that we could roll out, but also tools that we would have to make available to work with that service. And then talk a little bit about AI. So the role of artificial intelligence, and this is going to be big. The PSAPs are not going to be able to handle massive amounts of video coming in for security reasons, for data triage, or just the fact there aren't enough people sitting in the chair, or assuming that there's a good enough transport to the PSAP. So there's going to have to be some analysis of that. AI is also going to play a really key role. We could talk a little bit about it in the drone presentation, towards the edge of the network for like predictive analysis for crime, that sort of stuff. If you've got intelligence sitting behind a lot of the video cameras out there, they can be looking for anomalies in the environment. I mean, once they're out there a long time, they can say, what's the normal video that I'm looking at here? I'm seeing some anomaly there, and that could be a trigger to public safety, so they could know about an incident that may be happening or could happen. So AI is going to play a big role in this. And then also the issues of data privacy, regulatory, and jurisdiction. So that's great if you can share data, you're willing to share data. But what about if some of it becomes evidence? What are the regulatory rules and the jurisdictional rules over that? And that's not something that's going to be really handled by the service, but that could probably be the policy that gets built into the ISF customized tools. So those are some of the challenges, and by the way, like, as we do the panel discussion, we'd really like to hear your feedback on this, questions, comments, what have you been thinking about this, about data sharing amongst different public safety organizations. Here's a link to the document. It's about a 10-page executive summary up front, and then there's like a 50-page body, and then the document's about 180 pages. The reason it's 180 is we've got different appendices for different things. If you're very technical and you're interested in, how do you go about coming up with something like this, there's an appendice that goes into how you do the architecture, what's like the wiring diagram for what you're trying to do. There's an appendix on regulatory issues. There's another appendix on going through the 8 NIPSTIC IoT use cases, where we take the ISF and we go through that customization process for different use cases. So you have examples to look at to see how you actually use the ISF to customize for your specific use case. I think that's probably it. I guess we'll shift over and do the questions like as part of the panel now.
Everybody hear me? So thanks, Rob and John, for outlining the work that's been done on the framework. And we're going to kind of shift into a little bit of how to make it real. I know as a SWIC, what's important to me is, we're kind of down the good track on landline radio. So I can put, radios have to be P25 in my skip, and I don't have to approve grant purchases that don't meet that. But I don't have anything I could put in my skip yet on data. And I think having something like, the integration layer, whether a state has to develop their own or come up with this service, I have to say whatever CAT messaging, situational awareness software you buy, it has to be able to tie into this integration layer. And so I think that's, because if I could have the money to buy a messaging app free for everyone in my state, there would still be people that wouldn't use it. So, it's, you've got to have the ability to allow people to make their own choices. So I think this is a great approach to letting people make their own choices, but still have some interoperability. So Walt, why don't you talk a little bit about what you've done in the lab to look at the information sharing framework?
Okay, Well, by the way, one of the things that John didn't mention is that this framework on the video side work's been going on for a number of years. They've been dealing with the issue, it first started with the issue of, we understand there are a large number of police agencies in the Washington DC area. And each of them had their own system. So how do we let information sharing happen within Washington DC? And quite frankly, if you can resolve information sharing in Washington DC, you can kind of resolve it anywhere. But one of the premises or one of the tenets that we're pushing on this is that the one thing we want to really be constant is the presentation layer, okay? We want you to operate on your native presentation layer, because one of the things we learned from one of the first interoperability institutes is that we would go ahead and load up these applications on these devices and we'd give them to the first responder. Typically, it's what's done in disasters. Somebody's got a cache, and then they bring all of their devices in and hand the devices to everybody else. So now you're going ahead and going to the first responder. You're giving them a device they've never seen before. You've given them an application they've never seen before. You're now giving them information that they're not really familiar with, and say, by the way, go out and rescue all those people that are sitting in their flooded houses. That doesn't work. So the concept is that if DPS feels comfortable with their situational awareness tool being text maps, they view it on text maps, regardless of whose data it is. If you feel comfortable with your agency uses ATAC or in digital or any of the systems that are out there, we want you to be on your native system. We want to push that data to yours. The video is one part of it. The other part of it that we've been working on been the other information. Let's say, for example, location of first responders. Again, you get in a hurricane, you get in Houston during a hurricane, everybody knows where their own responders are. Nobody knows where anybody else's responders are. So how do we push that out? Two ways to do that. One of them is through standards-based solution. What are the standards for sharing location information amongst disparate agencies? There are none. And probably will not be within my lifetime. May eventually get there, but things like NG911, we've been working on since 2003. We redevelop the new standards, we modify them, we test them all the time. And so that's a well-matured area. Some of the other areas are not very mature, and some of them, such as location information, haven't even begun yet. So another solution to that is about 10, 12 years ago, the concept of developing APIs for your applications really started to come out. And there was an exponential growth in the areas of companies writing APIs to their systems. So if we can use APIs as a common thread and go ahead and then put an API gateway in there, the idea is that this API gateway will log on to ATAC as a user, pull the data out as a user. It'll log on to Blue Force and pull that information out as a user. So you still have the permission system in there because you don't get into that system unless you are established as a user with rights to pull it in. So the bottom line is the owner of the data still controls that data. Probably would turn it off for an incident. More than likely, they're going to keep it on all the time because you don't need to share that all the time. As was also shown on the ICF diagram, it's during the big disasters you've got to share it. So we put this API gateway in there, and we've been working with a company that developed one for the Affordable Health Care Act. Problem came in, the federal government came in and said, all right, we're in charge. We're going to be doing healthcare. And by the way, if you want to get reimbursed, you're going to submit your billing information in through the federal government system. And then so you've got all these hospitals are using Epic and all these other healthcare systems that are internal to the hospital. But how do I get that shared? So they worked with a company, was Computer Associates at the time. Computer Associates was later bought out by Broadcom. And so they built an API gateway that's currently used very extensively in the healthcare industry for sharing information between hospitals and the federal government. So taking that same concept, what we looked at doing is saying, let's put API gateways in there. And so we've got a project that's phase 2 that Rob was talking about. We've got a project that's about to kick off that will have basically some graduate students who will be working. These are graduate students in data management that will be writing APIs from some of the more common, more popular systems and it will be sharing data information across the systems. As John said earlier, you've got to figure out what data you want to share. If I've got a CAD system, I probably have 500-600 attributes in that CAD system. Not all of them need to be shared. So public safety's got to get together, say, all right, we need markers for where a hazardous material or where hazardous information is posted. We need this type of information. We need that type of information. So we'll take a small subset of that data and then share it across disparate systems. Ideally, in the long run, if we do end up going with an API gateway concept, realistically, if you look, for example, at CAD systems, there's really only, I would guess a small handful of CAD systems that are popular across most of the industry. If someone were to sit down and write those APIs for those common CAD systems, and then go ahead and actually put them into open source and make them publicly available, realistically, that API information, those gateway, the gateway coding could actually be utilized regardless of whose API gateway you use. We're not pushing, our intent here is not to push a Broadcom solution on the API gateway. It's just to do a proof of concept to say this could be done.
Can I compliment that?
Yeah.
That's in essence what the Skyline transcoding box is.
Yeah.
Most of these proprietary video formats publish APIs on how to talk to their system. But what public safety agency has programmers on staff that are going to be able to decode that and figure it out. So what that box is, that TS1000 that was shown in the architecture, is actually like a Dell server that has bundled on it all of the APIs to talk to most of all the video formats that are out there. So when you point video towards it, it goes, oh, I know what this is. This is Genetech. We know how to decode that and turn it into H.264 coming out the other end. So that's fundamentally what that Skyline box is doing for video. But like you said, and like Rob said, you can't build one giant box in the integration layer, because what it takes to talk to video is different standards and different formats than what it takes for GIS as an example, or what it takes for the healthcare system. So you're going to have a bunch of services and some cloud-based, some on-prem, to actually tackle the different types of content that's.
Yeah, so, part of the process here is going in there and saying, all right, in the information sharing process, we really almost start to create a common data dictionary that says, this represents a residence. It might be called something else in one CAD system and something else in another CAD system. So part of the process of normalizing the information is saying, in this system, this information equals this information, but it's also in disparate formats. So how do I rewrite and how do I republish that format? So it pulls information out of all the systems and then pushes that information back into all the systems. It's envisioned that probably you'll have some of the service providers will be providing this kind of service, hopefully in the future. Your AT&Ts, your Verizons, your T-Mobiles, your Amazons, your Googles, your everybody else. So we want this ultimately to be a competitive market that people can go to and buy the service and not have to run their own individual gateways.
So part of this is what Carlos said. You have to be able to say in your procurements that, yes, I want a system X. But one of the requirements for System X is it talks in this language to the integration layer. And as we start promoting this construct and specifying those kinds of things, when I was a SWIC, I would say, you get as much interoperability as you're willing to specify in your procurements and you're willing to pay for. But sometimes in the public safety community, we're not smart enough to know what to specify and maybe don't have enough big enough check to pay for it. So, look, the ISF is an attempt to try to create a common view and framework and vernacular to specify these things.
Well, and yesterday, for example, AJ gave a real good talk on what American Red Cross does and what they do and stuff like that. Where they really fit into this very well is during any major incident, they'll have hundreds of volunteers out there going ahead, driving the neighborhoods, looking for who needs help. Ideally, there's a lot of information that DPS and TDM and Army National Guard have that they can share with the American Red Cross. On the other hand, there's information that their volunteers are pulling in that would be very helpful to the Army National Guard and to DPS. So, until really AJ kind of brought this to us, really didn't kind of dawn on us that, yeah, actually, there are NGOs that are working disasters as well that need to be part of the ecosystem. They don't do response, but they support response.
Well, I spent 30 years with the Maryland Department of Transportation, so I would second that because DOTs are usually a big part of certainly the recovery phase, if not the response phase.
Yeah. I was working in emergency bodies 10 years ago and almost saw a gun battle when DOT shut down one of the roads here in College Station. And the local police basically said, you can't shut down a street in our town. And I said, well, this is a state highway. They said, well, yeah, but this is College Station. So the police chief and the DOT person were about to go at it big time.
So it was a people issue and that people process.
It was a people issue.
Technology.
Had they been on the same situational awareness system, they would have known that that road was being shut down.
Thank you, Walt. John, why don't you share a little bit of your experiences with kind of how you brought this whole thing up, with video specifically in the national capital?
Yeah, thank you for bringing that up. I did neglect to mention that. The Skyline product was actually developed when I was at Maryland DOT. I was there and I was the DOT rep to the Maryland Emergency Management Agency. I was sharing with AJ later yesterday that I was if you're familiar with EOC terminology, I was the ESF1 chair for 17 years in Maryland. So basically, if it was a major event, I was either at the scene or at the state EOC over that time period. So in Maryland, it's an integrated department. So you had the transit agency, the Port of Baltimore, BWI Airport. They were all part of the DOT. They all had camera systems and they were all different manufacturers and they were all on different networks. And I had rights into those systems as the emergency management guy. So I could get into them, but I couldn't do it from the state EOC because I didn't have the proprietary software on my laptop at the state EOC. So I said, this isn't right. So Skyline actually was the firm that came in and actually built the box that we're using here so many years ago to actually do that video transcoding and sharing. And so I was able to bring video from all of those state agencies into the state EOC. Well, flash forward, I retire from state government. I go to work for Johns Hopkins Applied Physics Lab. And the National Capital Region approached me and said, hey, you know that video thing you did for Maryland? Can you do that for the National Capital Region? And not being as smart as I am now, I said yes. And I actually had hair before I started that project. But so it resulted in about 4 years of an urban area security grant, or UASC grant from that region, to build out what is in use today. And it has about 200 agencies participating in about 17,000 cameras that are part of that network. And so this works. This is not just like this approach to the problem is not just it's a pragmatic approach. And you said it, Carla, you're always going to have people, you can buy the same solution and get most everybody on it as one way to solve the interoperability challenge. But the reality is that you'll always have outliers who don't want to be part of the system. And I don't mean that in a bad way. Every jurisdiction has certain unique business needs, and they're going to want to buy a product that meets those business needs. And so this approach basically says we accept that. And instead of forcing change on the data layer, we're going to build an integration layer once that can speak to many things and publish in a consumable way to the presentation. So, and one last thing on this, kind of a funny story. I'm sitting in a room about this many people, and most of them are carrying guns. And I said, who here wants to see the other people's video? And everybody's hand went up. I said, okay, good, we're making progress, right? People, process, technology. We're in a meeting, working through a process to get consensus. I said, who here wants to be able to direct the other person's camera? No hands went up. So I said, all right, we have our first requirement. They want to see view only rights. They don't want to be able to direct the camera. And what we did in that system was, it was two parallel approaches. Matt might appreciate this. When you enroll in the system, you're first vetted, and our Fusion Center runs the system, by the way. You're vetted, and you're given certain permissions in your role. And you have 4 security levels, 1 through 4. 1 being internet video, anyone can see it. 4 being, we'll have to kill you if you see it. So when you're enrolled as a user, you're given a security level 1 through 4. But what we also did, Walt, was each individual camera that's enrolled into the system is assigned a security level 1 through 4. So when I log in as a level 2 user, the only cameras that I can select are level 1 and level 2 cameras. And so we have tied the metadata to that camera, to the security level, and it matches up against the individual rights in the system as a way of ensuring that only the right people with the right permissions get to see the right data. So we built it into the system. So I think that's a little bit of what we did there.
I know at one time you had a diagram, if you didn't use an integration, box of some kind, and you tried to do the connections to everybody and everybody's camera, the lines blurred so much, it wasn't even spaghetti anymore, it was just a big blob. And so, the amount of work that would take would be astronomical, because every camera, you gotta start over. And so, having something like this really streamlines the work of how you bring in more organizations. So I think this is great. Rob, a little bit, I know you're still working through your proof of concepts, but what value can stakeholders get now from the document sharing, information sharing framework document?
Yeah, I'm sure John will have some things to add to it too, but I think, one is, it's good if you're going to do a procurement, it kind of gives you a checklist of a lot of things to think about when you're buying a system or a service, to make sure that you can secure it, you know how to manage the data, you know how to exchange the data, the availability of it. And I think the other issue that we're trying to promote, and that's why I had the 5G architecture up there, is it's one thing to go to, like, say, a CAD vendor and say, here's my operational and technical requirements so that I can share CAD data between CAD systems. But to me, the way things are going, especially if you've got to use CAD as a mechanism to ingest NG911, and you want to take that data and send it back out to a first responder on a wireless broadband network, to me, I would go to that vendor and say, here's the vision and the ecosystem that we're operating. Like, this is the end-to-end ecosystem between citizen to government, first responder, in and out of the PSAP, BCC ecosystem. What do you have now and what is your roadmap for the future? So, okay, you do CAD very well. We like the presentation layer. We're not going to change our CAD system, so it don't want to affect the data layer, the presentation layer. But what are you doing with AI? Like, are you doing any analytics? I mean, how can I take the data in your CAD system that meets my operational need, and how can I share that with another jurisdiction that has, as Walt said, like completely different names for the same things? Like, one's medical vehicle, one's ambulance, whatever. And so I think it's valuable for that. I think it's also valuable. We see a lot where we deal with SWICs, and there's like people doing LMR, there's people doing the wireless broadband, there's people doing alerts and warnings, there's people doing 911 and NG911. And the document is, I think, a good document to show, CIOs at the state level that, look, all of these systems are coming together, and there needs to be like an interoperability board at the state level where all of these people come together. I mean, one of the advantages of doing this ISF customization in Iowa is they have two boards. They've got an interoperability board at the state level and a 911 board. And we briefed both of them on this concept, but they're all talking together. So there's representation of all these different systems and technologies that are now merging together. They're not walled gardens anymore. And this is the methodology of kind of organizing that. And I think the other good thing about the ISF is in the appendix where we go through the NIPSTIC use cases, there are examples of stepping you through the process of what type of content do you want to share, who do you want to share it with, what are the technical drivers where you are, what wireless broadband service are you on, how are your PSAPs configured, do you have fusion centers. It walks you through a lot of that, so you can take some example use cases if you're going to go buy something and say, well, I'm going to get this product or service, I'm going to use it in this way. And if I step through the ISF process, it should help me figure out, what are those technical requirements and performance requirements to make sure that, you can discover the data, manage it, secure it, transport it, and then any analytics you want to run on it. So I don't know, you want to add anything else to that, John?
No, I think you really covered it. I mean, again, when I was a SWIC, there was no rule book. There was no, this is how you do it. We now have a bit of a playbook that says this is the things you ought to be thinking about. These are the questions you need to be asking. And I just would like to see people start to embrace it broadly, because what's happening, whether we like it or not, is these worlds are converging. LMR, everything's going IP, and everything is starting to converge. Our wireless networks have capacity to be able to deliver video to the hip. I mean, the capability is there, and these worlds are starting to merge, and yet we still have stovepipe systems and data silos that, over time, they'll come down because it's inevitable. The question is, how do we accelerate that? And the framework is a way of thinking about how to approach the problem for maximum benefit in each state and each jurisdiction.
I agree. Any questions from anyone in the audience?
It's still away.
Yeah.
Just an admin question, are we going to get copies of these slides?
Yes.
Yes, yeah, all slides have been made available, yeah. Right after the FirstNet announcement happened, I did a quick article in Mission Critical. There's a lot of talk about, all right, now we have LTE out there, problem solved. And basically wrote an article that said, no, we've resolved layers 1 through 4. The reality is now we're moving up to the harder stuff. Now the interoperability issues are in the application layers. And that's where the complication is. That's, with 3GPP has done a wonderful thing for us. They've standardized the wireless networks across the board. Everybody follows 3GPP. As far as the service providers go, life is good. You get up to most of the applications, there are, as I said earlier, there are no standards. It's just, they're not there.
I would agree. I think one of the things that Rob really brought out is that you're looking at your agency and you're solving your problem, but you do need to look at what tomorrow's problem is going to be and thinking about, specifically NG 911 and what that next definition of sharing data is going to mean, and keeping that in mind as you move forward with your concepts and your projects.
Yeah, I just wanted to second that. So again, the CAD example, like you can go to a vendor and say, I want these conversion tables. I want to create a hub or something or a gateway for me to share CAD data among these different systems. But what about that data format you standardize on? If it's like XML or JSON based, are you thinking you're gonna at some point be ingesting that NG 911 data? And if you've got to send that back out to a first responder, like, what data format does that need to be in? And what is the wireless carrier going to do with that so that they can prioritize that, make it a guaranteed bit flow rate in 5G terms, so that it has the priority and security to get to that officer? Because you can go out and send the data, but if the service provider doesn't give it the right priority, and the service provider is the only one that knows how their resources are constrained in the network once they get their network, orchestrated, you might have solved one of the problems, but you haven't really done something that fits it into that kind of end-to-end ecosystem. You've got critical data, and you don't have a way to really get it out with priority to the first responder.
Any closing comments, Walt?
No, I'm good.
Any last second questions going once? Thank you.
Yeah, thank you very much.